Hey everyone, Lakshay this side, and I welcome you all in today's session about what you should know before doing DoK. So let's start. Let me introduce myself. I am Lakshay, Internet DoK Community, Electronics and Communication student, open source enthusiast, and here are my socials just in case you wanna connect. So you are a developer and you're building an app. Okay, you use your front end, your back end, your database, and all the tools that were required. And now your app is ready and working fine on your system. Okay, now what happened? You want to share that with your friend. Okay, one of your friend. Now what we do as a developer, we build code and share it with others. Like we build the app and we share it with others. Okay, so to share it with your friend, you send your code to GitHub, you uploaded your code to GitHub and ask your friend to take it from there. Just in case you don't know about GitHub, you can see it as a drive where you can upload your code and share it with others. Okay, like we upload our files at Google Drive, right? Similarly, we can upload our code here. Okay, so following your instructions, your friend take the code from there and install and try to install there on our machine. Okay, but what happened? Code didn't work there. Your app didn't work there. But why? It was working on your system. Okay, so she asked you that it's no the app is not working, when you were like, but it works on my machine, right? So you checked all the code once again and like there were no problem. Okay, later on you found that your app required the version 7.00 of Redis and she was using 6.22 version. Okay, so due to difference between versions, the app didn't work. Also there was the mismatch of the databases, like your app required PostgreSQL and she was using EDB. Okay, now how will you overcome this problem? So one thing you can do is like you can update the version of Redis and change EDB to PostgreSQL. But then what will happen? The another app that she might be using, which use these dependencies, that app will not work, right? And you will not be using only one app on one machine. Now you will be using many of them. Okay, so how to overcome this problem? So to overcome this thing, we use the concept of containerization. We use containers, and with the help of containers, we don't have to worry about any of the dependencies, libraries to install. Okay, we don't have to. Okay, so while using containers, we don't have to worry about anything. Okay, so like what you can, what container is like what you can do, like we send the front-end database and all the stuff to our friend. Now what we can do, we can send those containers. And what is container? Container is a package. It contains all the instruction, all the scripts, all the dependencies, all the libraries, and including your code and including their versions, which whatever is required, your containers contain all that. Okay, and one more benefit of the container is that it is isolated from external environment. Okay, like if there is f1 and there is f1 and like there is a container of f1 and there is a container of f2. Okay, and both are using different versions. Like recently we saw that there was another app that was using 6.22 and your app was using 7.00, so both app can work now. Okay, so this problem is also resolved. Another is like these containers are portable. Okay, you don't have to worry about anything, you can just take them anywhere on any system and they can work fine. Okay, now we can see the architecture here of the containers. Like containers, like you have your CPU, RAM. Now let's see about the Docker. Okay, we talked about the containers. Now what is Docker? Okay, remember I talked about the container engine. Okay, you want to build a container, how will you do that? Okay, so to do so, what you can do, you can use Docker. Docker will help you to build a Docker container through Docker image. Now what is Docker image? Docker image is just a read-only template. Okay, by which you can create Docker container. We can say the container is an instance of your image. And how you will build the Docker image? You can build Docker image with the help of Docker file. Okay, we just talked about this, that the image is your read-only template by which you can like deploy your containers. See, we can't carry the container everywhere, right? Because container is the living instances, like they are running on your servers. Okay, so like if one of the containers get crashed due to any reason, okay, how will you build that again? You need something. So Docker provides you Docker images by which you can build them again. Now we talked about containers and we share it with our friend and everything is working fine. Now the code is working on your machine too. Now code is working on your friend machine too. Now later on you decided to bring your web app to production. Okay, so like you want to share it with world, and so to do so you bought a server and uploaded your code there. Okay, and by the end of the day your app is available for the world to use. Okay, but later on what happened, your web app crashed. Okay, like it stopped working. So again you are worried like what happened, so you just go and checked out that what happened to app, and you found that remember we used the front end, back end and database, right? So the inside the container when we packaged all the things, there was database also, like your PostgreSQL, and that stopped working. Okay, due to which your complete container crashed down, and due to which your complete website is down. Okay, so you run the code, did some code work, and you run that database this file once again, and your container is running again. Okay, but this will happen again if any of the containers went down. So how can we overcome this problem? So to overcome, so what we did, we packaged all the tools, all the items that were required to build an app inside a single container. Okay, due to which it caused a problem. So what we can do, we can follow the microservices approach. What is microservices? Rather than packaging each of the tool inside a single container, we can package individual tool into a individual container. Okay, like we can package our front end in one container, database in one container, our back end in one container, and like so. Okay, so this will solve the problem of like if any of the container is down, then it will not affect the other containers. But now one problem is there, like these containers are need to be connected with each other, right? So to just for an example, like when you visit any of the website, okay, and you log in there, so what happened, like if you work you interact with front end, right? You enter credentials and then website verifies it at backend. Now see, it verifies at backend. Okay, so it means they are connected with each other. See, similar thing happen here, like your front end needs to be connected with backend. Okay, and so how it will connect with to each other? And another thing is that this was about single container. What if there are multiple containers at production? You will not be using a single container. There will be hundred thousands of containers. So how will you manage all those containers? For an example, like you are using 1,000 containers and out of which 2 are not working. How will you find out? It will be very difficult for you. So don't you need something which you can rely on, which can manage your containers, help in communication of all those containers, right? And if any of the container is get damaged, so it can bring it up once again. Okay, and so to overcome, so there are some of the challenges of like using microservices we talked about, like if any of the container crashes down, it will be very hard to debug the things. Okay, there are security issues also. You can't monitor each and every container. Okay, and we just talked about the communication, like how they will communicate with each other. Okay, so to overcome this problem, we use Kubernetes. What is Kubernetes? Kubernetes is an orchestrator. You have seen into like musician, like how he comprises all the music and stuff, and how he like orchestrate the other musicians. Okay, similarly Kubernetes is an orchestrator, like it helps to automate your containers, provides self-healing to them, provides security, and also help to scale up them, and also provide in load balancing. Here are some things about the Kubernetes. So Kubernetes was developed by Google in 2014 and was donated to open source. Kubernetes has a wide community ecosystem, provides portability and flexibility to your containers. It also provides automation, it provides self-healing. It is a self-healing system, and there are many more benefits of using Kubernetes. So here is a Kubernetes architecture. If you are looking at it at first time, it may feels overwhelming, but it's not that much difficult. Like you are a developer and you can see here like this is your control plane. Through control plane you interact with Kubernetes. Okay, and like your users who visits your websites are interacting with this structure like Kubernetes node, and inside a node there is a pod. Okay, and inside pod your container lives. Remember we talked about containers, and those containers are inside those pod. Okay, so that was about the architecture. So what is stateful application? A stateful application is that have some state over the server, and what is stateless? That doesn't have any state. Okay, like we can also say that it saves the client data, and stateless is that doesn't save the client data. So let's understand these things through an example. Okay, so like you visit an e-commerce website, okay, and you enter your credentials and you log in there, and you added your items to cart that you want to bought. Okay, so then you went to your cart to check out, to go to the checkout page, but then you realize you want to add more items. So what will you do? You will simply go back and add that item. But when you go back, does it ask for does it ask for the login again? No, directly take you there. How that happened? Like it saves some state, like when you shift between one tab, it saves some state at the server, right? But what if it doesn't save the state at server? Like if that state is just saved at backend at the database, then your application will slow. It will slow up the application, like again and again the like front end has to make the request at the backend, and it will slow down the application. Okay, so it's better to have some state on the server. But the thing is, if we like create an analogy between the things that we learned earlier and about the stateful workloads. So like we talk about managing of those containers. Can Kubernetes manage these containers? Like there is some state over server, so can Kubernetes manage it? So, and is Kubernetes ready to run your stateful workload in production? And to get answer to this question, Data on Kubernetes community conducted a survey last year, and the results that we get from the respondents were surprising. Kubernetes has become a core part of IT. Half of the respondents are running 50% or more of their production workloads on it, and they are very satisfied and more productive as a result. And 90% believe Kubernetes is ready for running their stateful workloads, and majority, like 70% of them, are already running it. Now let's talk about Data on Kubernetes community. First of all, why this community? Kubernetes was originally designed to run stateless applications, but nowadays it is increasingly used to run data-centric applications like your databases and stateful workloads. And after discussions with thousands of individuals and companies that were running data on Kubernetes, it was found that there was a need to share some of the best practices and patterns to run data-centric applications on Kubernetes. And as a result of it, the Data on Kubernetes community was born. And you will be happy to know that Data on Kubernetes community has completed 120 plus DoK talks and 2 in-person meetups, and this is the second DoK student day that we are attending, and there are a lot more things you can find. But it is just about the running data on Kubernetes? No, you can do a lot more things here. Like talking about the contribution part, you can do whatever you are good at. You are good at design, you are good at singing, you are good at writing blogs. Whatever you are good at, you can do it here. And you can network with different people, make friends. You can meet people from different traditions, different culture. You can have enjoy with them, learn from them. Now, and there are different opportunities like which can help you to build your skill set. And with data on Kubernetes, you can grow your skills to next level. Now let's conclude what we have learned today. We talked about containers. Okay, why there was need of containers? Like you want to share your app to your friend, and there were problems like the problem about the version mismatch. There was the problem for the libraries, dependency, installation. To overcome all that stuff, we use container. And about Docker used to build those container through images. Okay, and then we talk about the microservices. Like monolithic approach causes the problem. Like if one of the thing is not working, that will bring down complete container. So what we did, we divided everything into a small container, and to manage those containers, we use Kubernetes orchestrator. Then we talked about stateful workloads, and then we saw the DoK report about running data on Kubernetes, and then we talked about data on Kubernetes community. And that's all for today. Thank you for joining me.